Alright, we're going to start doing some algebra now, guys. Aren't you excited? Alright, we're going to study a basic form of a linear equation. Alright, linear equation. And this is going to be in what we call one unknown. Alright. As we advance in algebra, we're going to study equations in two unknowns and three unknowns and so on and so forth. But we're going to start with just one unknown. Okay. So let me just add some colors here to help color code it. So the form that we're going to take is AX plus, let's see, I guess use yellow for the plus B is equal to some number C. Alright, now what's up with those A, B's, and C's, and X's, and all this junk, right? The reason why I color coded these, the ones in blue, the A, B, and C, which A, B, and C, we call these constants. Alright, and what they are is they're just known numbers, or what we like to call plain old numbers. Okay, plain old numbers. And A, B, and C can be any number, any real number. If you're unfamiliar with a real number, watch the previous video, and I did a nice explanation of all the different sets that we'll be working with. And we're going to confine ourselves to the real numbers right now. Later on, we'll get into complex numbers and all that fun stuff. But for right now, you gotta learn to walk before you can run, right? Alright, so A, B, and C are known constants. Alright, so if I were to, write the equation, 3x plus 2 is equal to 5, okay? What I mean by A, B, and C is that my A would be a 3, my B would be 2, and my C would be 5, okay? And that's all we mean. We'll just mean A, B, and C can be any number. They could be positive, negative. I could also have a 3x minus 2 is equal to 1. Okay. In this case, my A would be a positive 3, my B would be a negative 2, and my C would be a positive 1. We write the plus here basically just to include every possible number here, because remember, we can basically rewrite subtraction as plus negative, right? So I could say that this is 3x plus a negative 2 is equal to 1, and then there's your plus, and now we see B as actually a negative number. But alright, so how do we go about solving these things? Alright, the ultimate goal, let me change colors here, is to write it as x equals some other constant. I guess we'll just call that D. And don't worry about what we use to, the D, the A, B, C, and D. Generally we use, lowercase letters A through M to represent constants. And we use anything after M to represent variables. I actually should talk about variable. X is the variable. Alright. What a variable means is just that it's an unknown number that can vary. In this case, it's only going to have one solution because we only have one unknown. But if I have, later we're going to study, linear equations, y equals mx plus b, and then x can vary. I can pick and choose values of x, and then that'll allow me to figure out what a value of y that corresponds with it. Don't worry about that right now. So we're going to get into that later. But just remember that x is a variable, and if I have one unknown, then I can solve for that variable, figure out what that number is. And this has uses all over the place. You actually do it every day of your life. You don't realize it. If you go to the store and say it's in between paydays or so, and I only have $5 to buy a gallon of milk. Well, I know sales tax is 6 to 8%, depending on where you live. I know that I'm going to pay more than the actual price of that milk. So what I'm going to do is I'm going to multiply it by some percentage and then add that percentage to it. Well, that's algebra, okay? So, and more specifically, that's actually just what we're doing right here is linear equations. Alright, so let's do an example. Let's go back to our 3x plus 2 equals 5. I like that one. Alright, now, how do we go about solving? Remember, we want this to have the form, the solution is x equals some number D. Okay, we don't know what that number is yet, but we can manipulate this equation, because what we know that I can do anything to one side of this equation as long as I do it to the other. So whatever I wanted to do, I can multiply both sides by 3, and it doesn't change the fact that they're equal. I can subtract 2, I can divide by 3, I can do just about anything I want as long as I do the same exact thing to both sides. All right? So, a good analogy is if I were to give somebody a birthday present or just a gift. All right, so there's my gift, right? What do I do for that gift? I don't want them to know what it is right yet. I want them to actually work for it, right? I want them to open that present. So what I do is I put it in a box. All right, and please forgive my drawing skills. As you can see, I'm a mathematician, not an artist. So I put it in a box, and then I wrap the box, right? So I put wrapping paper over the box. Alright, now, what do they have to do in order to get that out? Well, they have to undo everything I did, didn't I? They have to first take the wrapping paper off, so we have to unwrap first. Alright, and then they have to unbox it in order to get to it. Alright, so we're going to think of the linear equation as the exact same thing. We're going to look at from left to right, and we're going to determine what was done to this variable x, because that's my Christmas present, or that's my birthday present rather. All right, so we want to unwrap it and unbox it. Okay. So what I did was, well, I first thing, if I look at the order of operations, right? Please excuse my dear Aunt Sally. First thing I did was multiply. So I multiplied 3 times x. So step 1, I multiplied 3 times x. Okay. And then step 2, I took that result and then I added 2 to it, right? Well, remember, everything in math is about doing and undoing. So if I want to undo this plus 2, well, to undo addition, we do subtraction. So my steps to solve over here, I would subtract 2, and then my second step, since I multiplied by 3 in the first step here, I need to undo multiplication. How do we undo multiplication? Well, we divide by 3. So just divide by 3. Alright, so let's see how that works in the real world here. So let's see, we'll go with the Khan Academy yellow tribute here. So 3x plus 2 is equal to 5. Well, what did we say we were going to do first? We were going to subtract 2. So I'm going to subtract 2 from both sides of the equation. And I like to write it underneath so it has an analogy to basic addition. So this is just 0 here, so 3x plus 0 is 3x. And then what's 2 minus 2? Well, that's just 0. So plus 0 is equal to 5 minus 2 is 3. Alright, here we go, fair enough. Now we're getting there. I'm going to have to clear off here. Well, this plus 0, what's anything plus 0? Well, anything plus 0 is itself, so I can just ignore that 0 or delete it altogether, and I can say 3x equals 3. Alright, now remember we multiplied by 3, so in order to undo that multiplication, back up here, we're going to divide by 3. So I'm going to divide both sides by 3, and look what happens here. The 3's cancel out, and that leaves me with a Plato 1, right? And then, 3 divided by 3 is 1, so we get the solution 1x is equal to 1. Well, anything times 1 is itself, so here we go. X is equal to 1. So our d is 1, which makes our x value 1. And if let me clear it off real quick. Alright, so now if I plug that x back in to check our work, which is something we should always do. So we had 3x plus 2 is equal to 5, and we want to see that this is, we found that x equals 1. We want to see if x equals 1 is a proper solution. So what I do is I replace that x in this equation with the 1 and do the math, and I should get 5 equals 5. So let's see what we get. We have 3 times 1 plus 2 is equal to 5. Well, let's see. 3 times 1 is 3, plus 2 is 5. And it does equal 5, so it checks out. Okay, I'm going to do some more examples in the next video, and hopefully I didn't go too fast. If there's not anything that you're understanding, please keep watching, because the best way to learn math is by doing. I can explain it to you all day long, but if you don't actually watch and work a problem with me, then you're really not going to get it. So see you guys in the next video.